Really, it's a very unfortunate event, but still, we should be really grateful to the people who sacrifice their life for the country. And at the border, really leaving their family, their parents, everything, leaving everything, they are protecting the country. At their expense, we are enjoying today. We are here like this very safely and comfortably means they were protecting us. So their services are very, very valuable. You can't just measure them. It's our minimum responsibility to do some. Actually, after the end of the class, I will say uh, some two, three quotations which army people will follow. Actually, you might have got them from Facebook already. You know that, that's fine. Now, in our class, uh, some students expressed that some more clarity is needed about the quantile plot. Okay. First of all, why we are studying this quantile plot and your box plots, and next we will be dealing with various other plots. You just guess and answer whether it is right or wrong. Because today I will explain you clearly. Because you asked, I remember about the quantile. I'll explain you. So I'll just slowly explain you how it is drawn with a very simple data. Then I'll interpret the same to the data that is given in our text. But the thing is, we keep forgetting. We just thought it is data pre-processing, and again we have started with this. Again, you have to in between recollect and remember that for what purpose we are studying. With that angle, if you look at the concept, then you will have again a better clarity. Getting my point? So what for we are going ahead with the data transformation? We are going ahead with the data transformation with an idea of, data pre-processing with an idea to clean the data, smoothen the data, right? So in this, we will be having some noise in the data. We thought what are the reasons for that? We may not be getting exact data. We will be getting some noisy data. We said because of network error or bit flipping and all, you get erroneous values and you have some missing values. So you have to smoothen the data. That is a important aspect we thought of, right? So we are using these statistical techniques to smoothen the data. Is it clear to you? To smoothen the data or to avoid the noise or to fill in the gaps of some of the missing values, we will be using the statistical methods. So first we studied the box plot. In box plot, what did we do? We considered the data. We are using the concept of median. So we have considered quantile boxes. First quantile means the first 25% of the elements. That is 25 percentile. Okay. So we have on x-axis, we have considered a specific length which covers up to 25% of the values. We call that quantile. And half of the values is median. And we consider the 75 percentage of elements where it comes on the x-axis. There you have drawn the border. So that will not be uniform because within first 25, the first 25% of the elements, suppose if you have 100 elements, the 25th element, it might come at a value of 50. Then by 60 itself, you can cover half of the thing, 50% of the value. After that, the 75% of the things might be covered at a value of 80. Later something else. Okay. So the dispersion will not be uniform. We are considering 25% of the element 50% of the elements. Okay. So that is how the box plot is giving how many percentage of elements are occupying up to this value. So it's a kind of measure. Now what is that? We have defined a quartile range, and if any of the tuples fall beyond that range, we consider them as outliers. And you have considered the minimum and maximum limits of the normal state. Beyond minimum and maximum are the outliers. That's how you have segregated the thing. Okay. So you remember your min max are not the exact data min max value. Please remember. Because I told you the class highest mark is 99 out of 100. The next highest mark is only 80. Then you have 78, 67, 78, 77. Like you have the marks. And the minimum mark is 5. But after minimum mark, the higher mark is 30 letters. Then your minimum is, you it will not say your minimum is 5 and maximum is 19. That will not give you an exact idea of the things that are abnormal, right? If you define min and max as 5 and 99, you don't get any measure. But the thing is, you consider first 25% of the elements, where do they end? So, first 25% of the students in the class, they might have covered up to something like 40 or 40. So, that is the first quartile. So, using those quartiles up to maximum you will find out, and the quartile range you will fix up. And beyond that, these are then only will say 99 is an outlier and 5 is an outlier, right? We should prove it elsewhere also. Then we say that he is extraordinarily talented. But if it happens only in this case, then it is suspicious. So like that, the outlier analysis will take place, because the outlier analysis is used in fraud detection. All this. Why we are focusing on data pre-processing this time is, this is the real world practical thing, the aspect of visualization. Even in the data warehousing concepts, you have Cognos and Informatica like tools. Informatica is a ETL tool. What is ETL? We just mentioned before. Simply, we will study about. Okay. And for ETL processing and all, use Informatica. Cognos means for cube building and for visualization, use the tool Cognos. So the visualization is a very, very important for the business people. They just wanted to know the behavior of the people, of the data. So to know the behavior of data and be the way in which their business is happening, visualization is needed. At the same time, to pre-process the data also, data visualization is needed. So for two reasons, it has got good importance. Even the NASHCOM, they wanted to have a syllabus for data analytics positions. There also they are emphasizing reasonably well on visualization and the statistics. So that's the reason why in your R13 revised syllabus, we have emphasized bit more on the visual. So that is the reason why from practical perspective, I am talking to you about visualization. Otherwise, just to cover the syllabus, I can give the formula, draw the graph, is done means done. Not that way. I want to make you really understand. Okay. So now, so here the necessity of this scattered plot or your box plot or your quantile plot, all these things is to have the visualization of data from one specific perspective. So each plot has got a specific perspective, right? For that reason. So in box plot and all, it is depending on the single variable. Single variable, how the tuples are behaving is on. Okay. So now your quantile plot is, in your box plot you are showing only the 25%, 50%, 75%, supposed min max values in the interquartile range, they are the min max values are fixing, and then the outliers you are fixing, right? That is one visualization. Here in the quantile plot, at every point of time the percentile score you will make. That is it also a kind of a plot, but wherein you consider percentile aspects at different levels. So I tell you, I'll just give you example. This also I have shown you in the last class, but with an idea to cover the syllabus because your mid is coming, I went little faster. But when you expressed that you had some doubt, I thought I should clear the stuff. My response. So what I will do is I will explain certain concepts wherein you require real visualization that is slow, and the concept which you can understand comfortably, which doesn't require much explanation, I'll move a bit faster. Because we have to have a compromise between coverage of syllabus as well as the concept, okay, in order to have. So you have a data set with values 78, 80, 80, 81, 82, 83, 85, 85, 86, 87. This is the data set. You have 10 numbers over here. 10 data points you have. So with these 10 data points, what we will see is we will fix up the frequency for this. So we fix the frequency such as your Fi is equal to I minus 0.5 by, that is equal to, first one is 1 minus 0.5 by 10 point. I'll tell you why you are considering even minus 0.5. Okay. So if you consider the frequencies like this, your F2 will be 0.15, F3 will be 0.25, etc. Your F10 will be 0.9. See, in this given set of 10, which is the median for you? That means up to this you have a 50%. 50%. So this is the median here, median. This will be the quartile. Like this, you have 75% and 10%, right? So here, if you consider the first element, you can say, sir, the first element can start with 0, but it is not 0th element, right? You have the first one. Some minimum stuff is needed. So the first one is, if you consider 10 things, the first one is 1/10th element, right? Do you agree? So the element starts from the 10th percentile. But here, in order to have some kind of visualization, let us start from the half of that interval. Because you have 10 points, means 1/10th is the space, right? 1 by n is 0.1. But we are starting at the 0.05 position. And from there, let us have the plot. Okay. So here, with that idea, these are the points on the x-axis. So the points on x-axis are your percentile things. The point on y-axis is the data value here. See, your first element itself is 78. So I'm showing the value 70, 80, 90 only. Because they are ranging from 78 to 87, right? So the first value is 78. It will be somewhere here. And the F1 is 0.05. So from 5 percentile, let us start the stuff. Okay. This is the point. Your F2 is 0.15. It is 80. 0.15 and 80 is and another is third point is also 80. So 0.25 with 8. Then 0.35 with what is the third value? 81. Just about. The plot will be something like. See how you got the frequency values, you are clear now, right? So I have shown you this example to basically how do you calculate the frequency values. With 10 it is easier to calculate. Why I have not shown calculation here is two reasons. One is in this textbook, he has not totally given the data set because what he has given is $40 some frequency, 200 elements, $43 some 200 elements. Like he has shown some tuples up to $140 he has shown, but intermediately has not given the total data. So unless you know how many number of points are there, how many quantiles you have got, you do not know. So in order to explain, you have shown the example with the 10 points so that you have 20 points to draw in the quantile plot. Rather 10 points are there, but 20 blocks are there total. 1 by 2n you are dividing with for the positions, but 1 by n elements will be there. Because in between also you get the middle points now by doing so, because you are starting with the 0.5 minus 0.5 you have taken, I minus 0.5 taken. So if 1 by n is the thing, 1 by 2n is the width, minimum width you are showing. Okay. In a similar way, he has shown, if you see the data set there on the on x-axis you have the frequency values. That much you know pretty well, right? Now on y-axis, it is the unit price of elements sold. That means he is showing 40 rupees, $40 some elements, $43 some other elements. Of course, the frequency also is given. How many are there? But here, please remember in your quantile plot, You are not bothered about that frequency part. It is a univariate thing I told you. That means within this data set given, within this data set of points, what is the minimum range and maximum range? And in between this, how the variation is there. That means 50% of the elements purchased in this were shown at this price. Got my point? That kind of assessment you will be getting. That means see this quantile plot now. In the data set, if you look at the data set, it started with $40. It showed $40, some 200 elements, some $43, 100 elements. So let's not worry about the frequency of it. That frequency of it you are considering for histogram. That's a different story. This is not for histogram purpose. Okay. So you are drawing. So 40 is the minimum point, right? If you consider that is the first point. See, it is not there aligned to 0. Please remember that point. You observe very clearly. It is a bit away from 0. So what is that percentile means? You have observed the prices like 40, 43, so and so up to $140. Let us suppose that number is some 50, then you are considering I minus 0.5 by 50th position as the first element location. Got my point? So that will be 0.5 by 50 if there are 50 points. So how many percentiles you have got means you count the number of points there, because in the actual data set he has not narrated all the points. So those many points are there. That by 2n is the minimum width of the frequency on the x-axis. Is it clear to you? And on y-axis the exact values of the price you have. Now what does this plot say? Okay, that's the question. So now this plot says, see, you have f values has not shown all those things. Please remember 0.25, 0.5, 0.75 and 1 has shown. Okay. That means here it shares 25% of the total elements in the given data set are pricing between $40 and point around $57 or something. This is below 60, right? The quartile can estimate in a point just above that point. Show that it is below 60. It is around $55 or something, right? So from this plot, what you can infer is around 25% of the elements in the given data set. Please remember, this is localized to the given data set only as far as this interpretation is concerned. So 25% of the elements are costing between $40 and $55. Got my point? That is the interpretation. Then about 0.5 you consider, it is somewhere like 0.5 right there. It is something like 70. The value is something like 70. So it implies first 50%, half of the elements in this, they are pricing between $40 and $70. So half of the transactions. So from that, what is that you will say? 50% of the population that are buying items in the stores are buying items worth from $40 to $70. That is the range. So that is one assessment the shopkeeper will have. So he will have more number of those elements with that. 50% are buying within this range only. At my point? And 75% people are buying within a range of something like $90 or something. It's between 80 and 100, right? So that kind of assessment you will have from this quantile plot. How much percentage of people are selling the buying the items within what range? That kind of knowledge is obtained from this quantile plot. Is it okay for you? Huh? So that is the kind of interpretation you will have from this. And the storekeeper wants to know, okay, how many percentage of people are buying. So for this, what is that you should have? Your transactions should be sorted in the order of the price or whatever. In that order you should have. Or else, of course, you need not have them sorted. I'm sorry. Even if unsorted data is there, once you plot it, they will be sorted. Okay. Once you plot it, the first point could be this, and the second point you might be having is something else. Maybe at the 0.75 location, but you will be plotting the stuff. But of course, you have to be there in the, you have to get it in the sorted order basically. Because unless you sort the stuff, you can't find the median and to which quartile it comes to unless you sort, you will not get it, right? Normally for a graph, the plotting is different, but which percentile it has to come means you have to have the sorted order there. Though plotting is random, but here as you have to find out the percentile stuff, you have to invariably sort. Reason. But you will get the angle. You will get the perspective. So this is the quantile plot. Is it clear to you now what kind of interpretation it is giving and all? Now QQ plot is nothing but it's a relative plot between, suppose this is the price in a store near engineering college. Suppose you have some other store near Two-Town police station or main road. Its sales patterns are different, right? Its sales patterns are different. So on the same day, let us suppose you have taken the readings in this engineering college shop and Two-Town police station near our main road shop. For main road, you will have another quantile plot, right? So now your QQ plot is a relative plot between these two. You want to compare the sales patterns of engineering college branch and Two-Town branch. Then what happens is there. Yes, this is the QQ plot. In QQ plot, what you will do is you will take same number of transactions. You have to take same number of transactions. Let us suppose the transactions are different at two places. At one place you have got 200 transactions, another place you have got 250 transactions. But you have to normalize the other one also to 200 transactions. That is how you have to consider the same number of transactions at both the places. Getting the logic? Then your frequency interval points will be identical. So here you are having the unit price. So the y coordinate of first plot and y coordinate of the second plot because the quantile point is one and the same, right? First one is, if you have 10 points, it is at 0.051. So at 0.05, what is the value in first plot? It is 40. At 0.05, what is the value in second plot? It could be 42. So your 40, 42 will be the first point. Please see this point. Okay. See here, both are branch 1 unit price and the other is branch 2 unit price. So branch 1 unit price and branch 2 unit price for first quantile plot, first quantile point. Are you getting this logic? Because the first plot, if you see previous one, it is at $40. For the second branch, it could be 42. So 40, 42 will be the point there. Similarly, the next quantile one. See this point. This is at 42 or something, but there it is at 45. Are you getting the logic? So, like this, you are drawing the relative points there. Now, at 45 degrees, you draw the slope line. Now, if you look at these points, you cross check. The dark points are at first quartile, median is the second dark point, 3 for the third quartile is the other dark point. So, if you look at different places, at the first quartile, how the thing is there? This is the first quartile point, you please come there. It is 62 or something, 60 and 70 means 62, whereas there it is 60 or something on y-axis. So, that implies first 25% of the elements are sold in branch 1 below $62, whereas in branch 2 it went up to $65 or something. So they purchased at a little higher price. So this is showing the relative purchase patterns of two branches. So this relative patterning could be at the same time at two different branches or at two different times at the same branch. Getting my point? That means during Pongal season, see the purchase patterns, they are very good. And after Pongal, when there is no much business and during slack season, what are the patterns? So you will have a relative plot between the sales at peak level in the same stores and sales at slack level in the same stores. How much difference is there? At peak level, probably first 25% people would have purchased items below $70. But slack time, it could be $50. So between slack time and peak time, how much variation is there in my sales pattern? For their analysis, that kind of plot is used. Getting my logic here? Why you will be requiring these things like? So for that kind of analysis. Hello, my dear friends from the colleges also. Please follow, because I thought today if I give you the practical aspect of it also while explaining, probably you will have some better grasp. So with that, I'm going little slow with a kind of explanation. So if you have still any doubts, please don't hesitate to mail us. I can clarify them subsequently, or I can just give a note explaining with an example also, because for explanation if time doesn't permit. Okay, because the visualization angle is an important aspect in practicality. So what happens is, I know in TCS and all, people say if they show good visualization using Cognos. Actually, one person in TCS was talking to me long ago, some 4 5 years back. Sir, I struggled a lot to reduce the execution time in an ETL process. I really achieved a very good performance with tuning the indices and all. Nobody bothered about it. But in Cognos, when I have shown that, see, this is the relative analysis like with some simple feature. I have projected it beautifully. And the client said, is a client from some Gulf country, it seems. Oh, you have shown my business things very well. Very good. You are a very bright engineer. He appreciated me like anything. Sir, but I didn't do anything. Just changed a small parameter and I have shown the visualization in a better way. Whereas when I have done on back end, some kind of real tuning using all my expertise, nobody appreciated me, the people say. So that is the importance the visualization has got. Because down the line, what people say is how much output you are getting, what is the impact of the output. For this, actually, my teacher also was telling, is no more, his name is Professor Bhaskar Ramurthy, he is from electronics, whom I respect a lot. Once he gave an example, Murthy, what your knowledge or interpretation doesn't matter. What is the impact that result has got matters. I tell you, an astrologer is there. Two people have come to him. He said, for one person, tomorrow sharp at 10:30, you will receive a letter from your brother mentioning about some topic, or you are from your father mentioning about something. Even the content of the letter, he says, gone. And another person came, he says, yes, you will get 10 lakhs lottery. After tomorrow, your ticket will get 10 lakhs price. Trust me, he says. Then both the predictions went accurately. But the person who receives the letter will think, oh, he predicted correctly. He will say. But whereas the person who got 10 lakhs price will come garland him, give him a big treat and say, you are an excellent astrologer. But as far as the subject or technology is concerned, both are the same. Both are predictions. Both have got some science to implement. So the visualization gives a perspective to the management or the client for his analysis. So that is the reason why the data analytics has assumed a lot of prominence because a lot of money is involved. Because what people say is in your outlier analysis, I said, you can predict the outliers and then with some statistical correlation, you will find out is a fraudulent thing or not like. I was told in 2001 2 itself, the fraud in the insurance industry is to the extent of $3 to $4 billion. So just with the outlier analysis, if the insurance company can really detect the fraudulent things very accurately and disclaim the fraudulent claims, their revenue drastically increases and the insurance premium also reduces for the people. Because if they save some millions of dollars, automatically the insurance premium will come down. See, suppose in a strike you burn some buses and all those things. It's a loss for the public. Finally, what happens? That comes in the form of a tax on your head on. Right? So if more fraudulent crimes are there and the insurance company doesn't bother, it comes in the form of premium on your head. So that's the reason why the visualization has got so much of importance. And in the entire data pre-processing step, your data transformation, data cleaning, noise elimination, all these things are taken care properly, then your data mining also will be perfect and the knowledge interpretation will be accurate. I have shown you a very simple example with the 10 things. If you just misinterpret something, missing values are there. If you just keep the average values there instead of the highest values, the entire interpretation has gone wrong, right? So that is the importance of your cleaning of the data before. Now the next plot is ఈ రెండు కాంటెంట్ కట్ తర్వాత come to next is the scattered plot. The scattered plot is, this is a bivariate plot. This is your unit price and the items sold. Here you don't have any percentile things. This provides a first look at a bivariate data to see clusters of points and outliers, etc. Each pair of values is treated as a pair of coordinates and plotted as points in the plane. In scattered plot, what you do is you don't join the points. In scattered plot, don't join the points. They are just scattered. Here they say clustering of values, clustering of points. See the items sold. Here what you can interpret is between $40 and $60, you have many items sold there. See, clustered purchasing, right? And another set is between 65 and something. Right? So like this, it is showing some clustering of stuff and outlier in the sense the farther points. Okay. Here, one thing you get is about the correlation. Here, whether there is any correlation between these two attributes or not is there obtained. About the correlation, I will just speak in the next minute. This is the one. What is the next step here in this anything? Otherwise, I will show you few more examples about the scatter. I have taken some more information from net apart from this to make you visualize the practical. Then only you will remember them. See, this is a picture about positively and negatively correlated data. See, the first one is positively correlated data. The second plot is negatively correlated data. Okay. This is another kind of stat. You show the next slide. This is totally uncorrelated data. There is no correlation between X and Y. Things is the points are. I'll show you how. Next. Okay. Then you come to the slides by desktop. I'll show you about part and correlation. This is from the net from the algebra lessons page from some website. What does this say? Have you ever been curious to know if one event affects another event? That's what we now. First of all, you have to know why correlation is important. Then only you will understand the remaining. If you know the importance of correlation. See, if I want to, suppose you don't like banana, or you have neither liking nor disliking towards banana, but I want to make you eat some banana. Then what I should say? Oh, banana, it has got good potassium content. So it will give you good thinking capacity because potassium is good for that. Memory capacity will enhance. Okay? Then it will be good for your kidney stones or something. So even if you do not have an empty stomach, if you have, still it is stomach filling one, good for your digestion. Like if I tell you some 6, 7 points, then oh, these are the benefits of banana. Sure, I will eat. Of course, if you are dead against it, that's a different story. Okay. Right. Similarly, about the correlation also, if I say these are the benefits you have in the business, then probably you will understand, right? One more thing is this data analytics part, especially the warehousing concepts. If you look at, people say that it is half MBA and half DBA. That means you have to know the business importance of it and the business requirement of it. Then you will appropriately fix the proper technical strategy. As a database personnel, you will fix up optimal SQLs, optimal table structures to handle the data. So that's why people say data analytics is half MBA plus half DBA. Unless you know the business perspective, you might be very good at data structures. You might be very good at databases. You can write very good SQLs. You given the information, you will normalize it. You write optimal SQLs. You create appropriate indices. Everything you have the knowledge. But if you do not know the business process, how do you find out which are the dimensions? What aspects you need to keep? What aspects you need to discard? Unless you know all that stuff, you can't fix the database, right? Once you fix the database, right, you'll do good job. But to fix the database, you have to have a very good business knowledge. But one more thing I have noticed in my experience in industry is a computer science personnel with good data structures and with good programming insight could grasp the business process faster than a person who has exclusive business knowledge and doesn't have any computer knowledge. That's my experience. That is the reason why majority of the computer science people are doing better, even though they take some other people also. Of course, there are exceptions. I don't say. Again, it is a generalization. So, as computer science personnel, if you are good at logic building and good at basic programming, your insight increases. So, the grasping also will be faster in the business analysis part. So, that's the reason why I tell people in the beginning, try to develop good listening skills. Because you have to understand what is the requirement of the client. So if you understand his requirements faster and translate them into advantageous technical specs and show something, and if you could show the good visualization, as I told you just now, the client will not leave you. He will always say, I want so and so person only. If you are going for client discussion, he will make sure bring that person for the meeting. Don't forget. He will tell the man. Then the company will be after you. Then you can demand your company, give me 10,000 hike, otherwise I'm leaving. Then he will say, no, 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 please, please. The client is after you. Yes, you can. I'm not kidding. It's a fact. So knowledge is power. So before the knowledge, the caste, creed, color, nothing will be there. Even if his own brother-in-law is there, he will drop him and give you because you have to deliver the goods to the client down the line. So there the recommendations will not hold good because tomorrow he has to deliver the goods. So in such area, no reference recommendations will work. Only references. Otherwise, he has to close the company. Once I asked one corporate company person, suppose if you get some recommendation from a top minister, saying that you give a job for a most useless fellow who cannot do anything. Said, yes, sir. If such kind of things normally will not happen, they also know that. But if that kind of recommendation comes, how we handle is, he will say, you give job to this person. Will say, sir, we are about to contact you very much. We have some thing from you. We are waiting for that. So we will put for some proposal that gives us a lot of profit. Normally, which we don't get, we will ask. Then we will calculate. Okay, if we give him the job for 1 year, we have to pay him around 3 lakhs, let us say. So we will ask him some 20 lakhs favor. So he has to do that. So because if he doesn't do that, he can't ask a second time what happened to the job of the person. So if he does the job, we got 20 lakhs profit. Then we keep the person. We always tell him, yes, you learn this like, and for 1 year we will feed him. We don't pay him anything. Nobody will talk to him. Nobody will come to him. He has to sit ideal, come and go home. So after an year or year and a half, he will be laid off by some other. So reading that, normally people will not recommend from top section. So that is how the people will manage. So here the only solution is to be competent. No other thing will work. So now the statistics and quality control technicians gather. You see the plot uh, move up. And, no, I'm sorry. I did not tell you what is the importance of this correlation. Correlation is normal. I told you, you have different heterogeneous systems from which you are deriving the data, right? So you will be having some redundant elements like customer ID, customer number, somebody else may call it with some other different name, but it is the same data. So is it the same attribute you want to find out? That's one. And some attributes are directly linearly proportional to the another attribute. The number of items sold and price paid, they are two attributes. The number of items sold is directly proportional to the price paid. So you can eliminate one field, right? Because some of the fields are derived ones from this straight multiplication. So you need not have a database total column for a million record table, right? Whatever value is needed, you can compute because computation is much inexpensive, right? So you can avoid. So for that kind of thing, then how do you know that these elements are directly related to each other? That is through your correlation analysis. So if you find out the correlation coefficient of two attributes using the statistical formula, you will say that whether both are in direct proportion or indirect proportion, or there is no connection between those two. That will be obtained. So you use correlation analysis like that for eliminating certain attributes. Okay, in a dimensionality reduction part, you will be using the correlation. At the same time, to know the data behavior also. One thing is, in your textbook, he said your quantile plot is there. You can draw quantile plots of several attributes also. It will be an expensive task. That's a little story. Now, let's stop. Now, how this correlation is? Roll up. This is hours of study and the scores you obtain. See here, studied for 3 hours, got 80 score. Studied for 5 hours and got 90 score. Studied for 2 hours and got 75 score. 6 hours studied and got the 80 score again. 7 hours he got 90 score. 1 hour only studied but got 50 score. See, these are the things. Now if you plot them, of course, certain values may have more than one result. 7 and 90, 7 and 85, 7 and one. Somebody studied for 7 hours and got 90, 7 hours 85, 7 hours and 100. Okay. So this is how the points are. This is showing a kind of linear hike, right? Because you know linear regression you have studied. What is linear regression basically? What is linear regression? Anyway, I'll talk to that linear regression angle also, because in the next plot you have to know about the linear regression aspects. See, have you not studied the least square approximation in your first year, right? You have studied some numerical analysis part, least squares approximation. What is the interpretation of least squares approximation? Tell me. What is the meaning of your least squares approximation? Just studied, you have worked out a problem, you got the marks in the exam, but you don't know why you have studied and what you have, right? That's the reason why I tell you before studying topic, one should know what is the importance of the topic, why we should study the topic, what is the outcome of this topic. See, in any system, if you observe two variables, some x and y, one is dependent or independent variable, you get some points plotted in some. Okay, you get the points plotted in some. Covering all those points, if you draw a diagram, suppose these are the points. Now you want to connect all the points means right. This is the curve drawn covering all the points. But do you have any equation for the curve? Can you fit an equation for this curve? First of all, why do you fit an equation for the curve? Why do you need to fit the equation for the curve? Huh? Why do you require to fit an equation to the curve? Because these are the statistical, these are the observations you made. Okay. So this is some experimental data in which you found that some independent variable x and corresponding value of y, x and y, how they are varying at different intervals of x, how the y value is varying. For different x values, how the y value is varying, you have plotted. Okay, then why do you need to extend this? Means You want to find out the behavior beyond the interval also. You need to, right? You want to have, okay, you have started from x is equal to 1, y is equal to 5, x is equal to 2, y is 8, x is equal to 3, y has become 9, x is equal to 4, y has become 7, x is equal to 5, y has become 6, then x is equal to 9, y has become 10. So it is coming up, going up, coming down, going up, like it is oscillating. That is how you made some observations. But now you have the observations up to x is equal to 10. But after that, you want to know the value of the further things beyond also. When x is equal to 20, what could be the value of y you want to predict? Depending on that prediction, you have to take some decisions in future for your analysis. Okay. So how it is going to predict means you have to fix up some equation that passes through the majority of the points, right? It could be a linear equation, it could be a quadratic equation, or it could be any polynomial of any order. It could be a polynomial of third order, fourth order, or 2.5 order or fractional orders if you still want to fix up. So, which is the best fit curve to give the accurate results? So, finding out that is called the regression analysis. Okay, that is the regression analysis. So, linear regression means you will be fixing up a straight line that satisfies this data. Okay, because these data points are not exactly forming the straight line. So here the assumption you make in the linear regression is, I'll come to the correlation analysis. I will not, so once you have the points like this scattered, you will be drawing a straight line that passes through the intermediate values kind of thing. So here what you are thinking is, these are the results due to some experimental error. So you are finding out some average point. To average point, you are minimizing the errors. So you are finding out some average point wherein the error from the central point to these points is minimal. That is called the least squares approximation. So you have a formula, derivation and all. I don't remember all that. I am just giving you the physical interpretation. So you are fixing up a best possible straight line for the given data set that minimizes the error. So by drawing that straight line, what you can do at any point of x, using that straight line equation, what is the value of y you can find. That is your least squares linear approximation. Similarly, you can fit polynomials of different degrees and functions. So that is exclusively statistics part. But we are not the statisticians to go deep into everything again. We can't go deep and research on every statistical measure, but at least it is sufficient. What is the statistical measure? Where do we use and how do we use? When do we use? If you know that, then it is up to you to apply this technique at an appropriate time, right? Getting my point? So which technique is useful where? You will find out depending on your expertise and your experience. So for that, you should at least know what is the fundamental principle of this technique, how it goes. Okay, so here you show the plot. So if you here look at this, though the points are not exactly the straight line, through your linear regression, you can draw a line. And how is the slope? X is proportionally varying with Y. Okay. So it is a positive correlation, you will say. How effectively it is correlating from the correlation coefficient, you will find out. That I am going to tell you right now. Next, in the bottom, next, come down to the bottom. ఇందులో కిందకి చూపిస్తాను ఇంకో గ్రాఫ్ ఇంకా కిందకి రండి. So the data displayed, you have a positive correlation in this. ఇంకా see, okay, you have again how much positive the correlation is. See, if you look at this, these are highly positively correlated, these points. You look at the another plot, see how the points are scattered. Still you have a positive correlation here, but it is low correlation. The points are getting my point. If it is perfectly correlated with a correlation coefficient of 1 means everything will be on the straight line, like item price of price of 1 pen is 10 rupees. So 2 pence is 20, 3 pence is 30, 4 pence is 40. It is a straight line going through the middle of the thing. The slope is 45 degrees and straight linear graph, right? Then it is a perfectly correlated. Okay. So similarly, let us suppose if the different attributes, but they represent the same quantity. Let us suppose in two different data sets. If you draw a correlation between them, if they are really perfectly identical, you get that kind of perfect. Right. See, come down now. So it's a low positive correlation. Now you have negative correlation on the other side. See, it is in an opposite direction. This is a perfectly highly negative correlated. This is low negative correlated. Come down. Here in this case, you don't have any correlation. See, it's just like that. You have all the points scattered. Right. Now, he is giving another simple example. Here, like that, if you feel like drawing a correlation table, he is showing two attributes for which the correlation is drawn. It is perfectly correlated, but it doesn't have any relevance. So you have to use common sense also. That's what it is. Suppose you solve a quadratic equation, let us say. You have got the answer as -4 and +3, let us suppose, for x. Okay. And if x is the price of some item, let us say, which value you will consider, -4 or +3? +3 you will consider, because no item will have a negative price, right? So though you have the theory, you have to use your common sense also to fix the value. Here what he has shown is, during the month of February and March, the weekly number of jars of strawberry jam sold to at a local market in New York was recorded. On the same time, the number of copies of a popular classic music music CD sold in Florida was recorded. So the strawberry jam sales in New York, CD sales in Florida of a music album. When they have, see, 5 jars, 25 CDs were sold, 7 jars, 30 CDs were sold. Like some point, he has drawn the correlation is perfectly linearly correlated. So that doesn't mean if you sell more number of jam bottles, you will have more number of CDs sold. It's meaningless, right? Absolutely no correlation between jam selling in New York and CD selling in Florida. So if just the data is giving some correlation means you cannot say that they are really correlated. You have to be very careful. Again, the similar astrologers joke just for a while, for a change. There was one astrologer, he is good at theory. Okay. So he went to the king's court and the king was having one very precious stone in his hand. He closed that. Then he asked the astrologer, what is there in my hand? So he is just making the critical interpretations. He said, it is a very valuable stone. Very good thing. What is the color of the stone? Red. Very good. The stone has some hole in the middle. Very good. Then he asked, now tell me what it is. Then immediately the astrologer said, it is a grinding stone. అంటే మనం తిరగల రాయి ఉంటుంది కదా, పూర్వకాలం తిప్పేవాళ్ళం, మధ్యలో కన్నం ఉంటుంది, అది స్టోన్, వుడ్, ఎవ్రీథింగ్. అంటే హిస్ ఇంటర్ప్రిటేషన్ ఇస్ కరెక్ట్, బట్ హీ డజంట్ హ్యావ్ కామన్ సెన్స్. Can you hold the grinding stone in your hand and close it? Is it a precious stone? So he is theoretically good, he doesn't have common sense. So you should have common sense also. Rather, the business process knowledge is also needed to interpret the results very accurately. So don't commit this kind of mistake you wanted to do. Okay. In correlation. Next, I think come down. So next slide. So this is one slide. For your sake, I have just explored the net and got some of these slides to give you a better insight. And what is the scatter plot and how the scatter plot is related to correlation, because I have shown you the scatter plot before. The scatter plot gives you, because what is the scatter plot is an XY plot straight away. So this gives you the correlation of two attributes. So this shows the correlation also your scatter. It's not only showing how the outlays are there and all, it is showing where the focus is there, clusters are there. Apart from that, what is the correlation of these two attributes also will be obtained from scatter plot. Now you just go down. I'll show you one more specific thing here. Of course, linear, zero slope, stronger. This is one kind of thing. Positive slope. This is the negative slope coordination. And some of the scatter plots is showing at the bottom. Non-linear positive slope, non-linear negative slope, non-linear zero slope, and weak correlation. You have correlation, but the correlation need not be linear. It could be non-linear correlation also. They're showing. I wanted to show you one important plot here. This is what I just wanted to show you, because what I have done is I was exploring, because some data forms the normal distribution, right? In normal distribution, what is the behavior? At the average boundaries of your mu minus sigma, right? Your average point is central point. That minus sigma and plus sigma, if you consider the area in the normal distribution curve, that is the maximum, right? So if a data follows a normal distribution kind of thing, how your scatter plot will be? Or it could be some nonlinear correlation. So that point I would like to just show you. See, a scatter plot below shows relation between two variables. See, it is negatively correlated up to the midpoint, and again it is positively correlated. So he is asking the question, is the relation strong? The slope is positive. Is the slope negative? 1 only, 2 only, 3 only, 1 and 3, like he is giving explanation at the bottom. The correct answer is A. The relation is stronger because the dots are tightly clustered around the line. Note that the line doesn't have the straight for relationship to be strong. In this case, the line is U-shaped. So you have the strong correlation, he says. Okay. So like this also you'll have the scatter plot. Across the entire scatter plot, the slope is 0. In the first half of the plot, the y value gets smaller as x variable gets bigger. So the slope in the first half is negative, but in the second half, the slope is positive, and the y variable gets bigger as x variable goes in. And when the slope is positive, one half of the scatter negative, another half, the slope for the entire scatter plot is 0 is come down. Okay, you can stop it there. So that is how you will have different correlations of the data. With the scatter plot, you can find out the kind of correlation. But qualitatively, how do you find the correlation? One more curve is there. Curves part. Then I will come for the correlation coefficient, because at least the correlation part I can. So you have the scatter plot. Another is a loose curve. Loess. Loess curve. What is this Loess curve? This is called local regression curve. This LO stands for local, ESS stands for regression. Local regression. What is this local regression? Because you have your scatter plot, right? And the scatter plot, the, the curve shows here also the correlation aspects is 1, and the important aspect is how smooth the curve is and what kind of rather equation you can fix for the regression, because this depends on two variables, alpha and lambda. There are two values, and your alpha ranges from 1 to 4, your lambda, how it becomes 1 or 2 or something. I'll tell. The lamb alpha is called the smoothing factor. If alpha is 1, it's a perfectly smooth curve. If alpha is less, it is less smooth. That's one. And second thing is If your lambda is equal to 1, it is a linear regression. If your alpha is equal to 2,